Class 9, Chapter 9, Science, Force and Laws of Motion. Force, generally pull or push, is known as force. In the lab, it is measured by spring balance. In physics, we call the force which changes either the speed or the direction or the shape of an object. There are different types of forces like force of gravity, electrostatic force, force of magnet, and the force of friction. Broadly, they can be further divided into two: balanced forces and unbalanced forces. The system of forces which does not make the body to move, make it at rest, is called as balanced forces, and the system which makes the body to move is called as unbalanced forces. Two forces acting in opposite directions are subtracted to find out the net force. Like 30 Newton minus 10 Newton, net force will be 20 Newton. There are different examples of force shown here. Then there are forces like muscular force is the force in contact. It will not be able to interact until and unless the boy touches the almirah and makes it to move. So muscular force is a contact force. Now the chapter has 4 parts broadly: 3 laws of motion and the conservation of momentum. We start with the first law of motion, which is called as the law of inertia also. Second law is called as law of momentum, and the third law is known as the law of action on and reaction. First law, or the law of inertia: if an object is at rest, it will continue in its rest position until and unless an external force is applied on it. Also, if a body is in uniform rectilinear motion, will continue in its motion until and unless an external unbalanced force is applied on it. Then what is inertia? Inertia is the property of an object by virtue of which it is unable to change its position of rest or motion. Example 1. When a horse suddenly starts running, the rider falls backward because of inertia of rest. When horse running fast suddenly stops, the rider is thrown forward because of inertia of motion. Dust is removed from the hanging carpet by beating it with the stick. Initially, the dust and the carpet are at rest. When the blanket is beaten, the blanket comes in motion, but the dust particles remain at rest and they come off from the blanket due to inertia of rest. Another example which you can perform in the lab or at your home: there is a glass, there is a card and coin. When the card is flipped, the coin falls in the tumbler due to inertia of rest. When there are coins, carom coins on the carom board, and we strike it, the lower coin comes, only the lower coin comes. Why? And the rest of the coin remain there only. Why do the rest of the coin remain there only? Because of inertia of rest. Example 5. Fruits fall down on sacking a tree because of, again, inertia of rest. Now to start with the second law of motion, an idea about what is momentum, its formula, unit. The product of mass and velocity is called as momentum. It is a vector quantity. Its notation is P. Thus, the formula is P is equal to mv. Now the Newton's second law is law of momentum only, and it states the rate of change of linear momentum is equal to the force applied. In the direction of force is always the direction of change in momentum. So it can be written as d net is equal to mv minus u upon t, and in the differential form it is written as dmv upon dt. But in class 9, you remember the formula F is equal to ma or F is equal to m v minus u upon t. Conservation of momentum. Second law says force is equal to rate of change of momentum. And that rate, when there is no external force applied on it, the force is equal to 0 and the momentum is always a constant. Thus, in the absence of external in the absence of external force, the linear momentum of a system is always constant. Also, the second law of motion written as the rate of change of momentum is equal to mv minus u upon t, as I told you, or F is equal to ma, both the forms, and they can be derived from each other. The examples which can be explained on the basis of second law of motion. Why a cricket player pulls his hand gradually while holding a catch of a ball? In order to increase the reaction time, so he felt less force on his hand. Now in this case, you will write the formula F is equal to mv minus u upon t. He tries to increase the t as much as possible so that the force is decreased. An athlete runs for a certain distance before taking a long jump because the momentum he possesses due to the run will make him to cover long distance. Force is a vector quantity. It is cause of acceleration. Thus, F is equal to ma. In the formula, if we put the value unit of m, that is kg, acceleration, that is meter per second square, the unit of F is equal to kg meter per second square, and that is known as Newton. In short, it can be written as N, capital N. Also, we can derive the second law. Acceleration is directly proportional to F and inversely proportional to m. Thus, A is equal to F by m. When A is equal to F by m, F is equal to ma, or m is equal to F upon A. Now we can derive the first law of motion by the second law of motion given by the Newton as derived here. F is equal to ma or mv minus u upon t. Thus, Ft is equal to mv minus mu. When F is 0, the left hand side becomes 0 and it is mv is equal to mu. M will cancel out, thus v is equal to u. Now v is equal to u can be explained as the body will continue in its state of rest or in the uniform motion until and unless there is no external force acting on it. Newton's third law of motion is also known as the law of action and reaction. It states every action has its equal and opposite reaction. Now what is action? The force acting by A object on B, we can call it as action. Then the force applied by B object on A is called as reaction. And the Newton's third law of motion says action and reactions are equal in magnitude and opposite in direction. Now there are different questions which can be explained on the basis of Newton's third law of motion. While walking, we press the ground in the backward direction is action, and ground will push us in the forward direction due to reaction, and they are equal and opposite in direction. While swimming, have you observed? We push the water, or the swimmer push the water at the back, and water will push the swimmer in the forward direction. The recoiling of gun, must have observed while firing, we feel a jerk, and that is called as recoiling of gun. What is the reason about it? According to the Newton's third law of motion, gun pushes the bullet in the forward direction. Bullet will push the gun in the backward direction with the equal force, and that is why the gun recoils. Another example, as the sailor jumps in forward direction, the boat moves backward due to the action and reaction law, that is the third law. And a few other examples. Now this is an activity given in NCERT, also we can perform it. That we tie a string in between the two supports, and we have a straw in the string, and then we take a balloon and we inflate this balloon. Holding it tightly, we try to paste it on the straw. Now when we leave the balloon, the air will move to the left, is action, and that air will push the balloon in the right due to reaction, and the balloon will move to the right. Now what I have shown you here is also the example of the rockets. How does the rocket work? The fuel is burnt inside the rocket, and when the gases are produced, these gases are thrown out with the nozzle with the high speed, so that the momentum is high and thus the action is high. Now these gases will push the rocket up or forward. Thus action and reaction is also the working principle of jet or the rocket. Last part of this chapter, explanation of Newton's third law, that is and is given by the law of conservation of momentum also. Consider two balls, masses m1 and m2 respectively, with the initial speed u1 and u2, say in the same direction. Now when they interact for the time t, they exert the force on each other. The one force will be called as action, the another force will be called as reaction, and they will be equal to each other according to the Newton's third law. Now after the interaction, they move with the velocities va, v1 and v2 respectively. Then the law of conservation of momentum can be derived as the Newton's third law, FAB is equal to minus FBA, that is action is equal to reaction but opposite in direction. By using the Newton's second law of motion, when we keep the value of FAB and FBA, that is in the second line, MA into VA minus UA upon T is equal to minus MB VB minus UB upon T. When we solve this expression, we will get MAUA plus MBUB is equal to MAVA plus MBVB. Now if we look at the left hand side, this is the total momentum of two balls before collision. And what is the right hand side is the total momentum after the collision. Thus, we can state as the initial moment, sum of the initial momentum of the balls before the interaction is equal to the sum of the momentum of the balls after the interaction. And this expression helps us to solve number of examples. Thank you.